You're welcome to my YouTube channel. My name is Salami Dini, and last class we started mapping and function, and today we'll be looking at the continuation of mapping and function, and what we'll be looking at today is the types of function. And when we are talking of the types of function, we have what we term as the one-to-one mapping. We have what we term as the one-to-one function, and that is the same thing as the injective mapping. We have something we term to the onto mapping. And when we are talking of the onto mapping, we are talking of what? Of the surjective. The onto mapping means surjective. And also we have what we term as the bijective. We have what we term as the many to one. We have something we term as the identity mapping. We have something we term to the constant mapping. So these are the types of mapping we want to look at. We said we have the one-to-one function, which is the injective. We have the onto mapping, which is the surjective. We have the bijective. We have the many-to-one. We have the identity mapping, and we have the constant mapping. So for this video, we'll be picking them one after the other, looking at the meaning. Now, when we are talking of the injective mapping, what is the meaning of injective? We have said the injective is still the same thing as what? As one-to-one function. So from the word one-to-one function, so that means every element in the domain is having a distinct element in the codomain. Do we get that? So when we are talking of injective, what is the meaning of injective? Every element in the domain, which is the input variable, will be having a distinct element in the codomain. But note that there is a condition. It must not overlap. So that means if we are having a function that it is one-to-one, that means one element to one element and is overlapping, that will not make it to be injective. So when we are talking of injective, we are talking of situation like this. A, B, C, we can have it as 1, 2, 3, and let's say 4. That means A is leading to 1, B is leading to 2, C is leading to 4. Can we see it now that it is one-to-one function and it is not overlapping? So if we are having something to be like this, that will not make it to be the injective. Do we get that? That is explaining the principle of it must not overlap. So these are the examples of what? Of bijective. Let's look at another example of that. We have 1, 2, 3. The input variable is 1, 2, 3. Let's say the output variable is 4, 5, 6. So that will lead us 1 to 4, 2 to 5, 3 to 6. So these are what? The examples of what? Of injective. But we are not looking at the graphical representation. What we want to look at basically is for us to know the conditions that will make a function to be injective. Do we get that? We have looked at the graph, but now we want to look at the conditions that will make a function to be injective. Now, for the conditions that will make a function to be injective, the first thing is for us to note that they are going to give us a function of x. Now, the second thing we have to do is to equate our f of x to f of y. And also, the third thing is this, that if your x is the same thing as y, that makes the function to be what? Injective. Do we get that? These are the conditions for a functions to be injective. The first one is what? The condition is what? Is they are going to give us f of x. You equate your f of x to f of y, and after that, at the end of the day, if you can prove that your x is equals to y, that makes the function to be injective. Now, based on that condition, let us look at this question. They said if f dot dot r to r is given as f of x is equals to 2x minus 5. They said it's f of x injective. So for us to solve this, what is the meaning of RR? R means your domain is real and your codomain is real. You know R stands for real number. So that means your domain is real and your codomain is real. Now for us to solve this, we are not having any input variable. So that means we have to use the condition. They gave us f of x, and we have said it, if you have f of x, what will you do? You get your f of y. And what is f of y? Anywhere you are seeing x, you put your y there. So that means we are going to change this to 2y minus 5. And what is the second condition? The second condition says we should equate our f of x to f of y. So if you are equating your f of x to f of y, what do we have? 2x minus 5 is equals to 2y minus 5. And from this we cancel this, 2 we cancel 2. So what do we have? We have x is equals to y. And since our x is equals to y, that makes the function to be what? Injective. You can see that it's simple. So just know the condition, change your f of x to f of y, and after the whole thing, if you can show that your x is equals to y, that makes the function to be injective. Now let's look at this function. F of x is equals to 1 over 2x. They said, is this function injective? No. So how can we solve this? Can we make this function to be injective? So since they are giving us f of x, we are going to get f of y. And what is f of y? That will give us 1 over 2y. And after that, we are to equate our f of x to f of y. And if you equate your f of x to f of y, we have 1 over 2x over what? Over 1 over 2y. And that will give us 2y is equals to what? 2x. And what do we have? Y is equals to x. And the same thing as what? X is equals to y. So since these two functions are equal, that means the function of f of x is what? Is injective. Do we get that? It's simple. Now let's look at this again. They said if f to r is given that f of x is equals to 2x plus 1 over 2x minus 1. They said is f of x injective. So we are still looking at the injective aspect of it. So what is injective? We have said it, injective means one-to-one. And we have looked at the conditions. So making use of the condition, they have given us our f of x. That means we are to get our f of y. And what is f of y? You change your x to y, and that will give us 2y plus 1 into what? Into 2y minus 1. After that, what are we going to do? You are to equate your f of x to f of y. Do we get that? So if you are equating your f of x to f of y, what do we have? We have 2x plus 1 over 2x minus 1 is equals to, what is your f of y? That will give us 2y plus 1 over what? 2y minus 1. And if we can make this function to be equals to x is equals to y, that means the function to be injective. So let's attempt. So that means we have to cross multiply. That will give us 2x plus 1 into what? 2y minus 1 is equals to what? 2x minus 1 into what? 2y plus 1. And then we expand. That will give us 4xy minus 2x plus 2y minus 1 is equals to expand that 4xy plus 2x minus 2y minus 1. Wow. So after having this, then let's simplify. That means 4xy can cancel 4xy. What again? Minus 1 can cancel minus 1. So we are going to be having minus 2x plus 2y is equals to what? 2x minus 2y. So collect like times. If you transfer this man here or you transfer this man here, we are going to have it as well. 4x is equals to what? 4y. And at the end of the day, our x is equals to y. So therefore, the function of 2x plus 1 over 2x minus 1 is what? Is injective. So looking at this, that is injective. So that means we have talked about it, that what is injective? Injective means 1 to 1, and it must not overlap. And apart from 1 to 1, every element in the domain must be having a distinct element in the codomain. Now let me quickly explain that. If we have this 1, 2, 3, and we have, let's say, A to 1, and we have C to 3, this function is not injective. Do we get that? Because injective, every element in the domain, not at least one, every element. So that means B is supposed to be linked with something. So because B is not linked with anything, it does not make it to be what? To be the injective. Now let's look at it. We have to look at the second aspect, and the second aspect is talking of what? Of the onto function or the onto mapping. So when we are talking of the onto function or the onto mapping, what are we trying to say? We have said it's still the same thing as what? As the surjective. So we are looking at the onto mapping or the surjective mapping. And what is the meaning of surjective? First of all, understand the meaning. Now, surjective mapping simply means that every element in the codomain is having at least one element or one pre-image in the domain. Do we get that? Surjective mapping again, it means every element in the codomain, which is the output variable, is having at least one element or pre-image in the domain. So for example, let's start with the graphical representation. We have ABC, we have 1, 2, 3. If we have A to 1, B to 2, and C to 3, this is what is surjective, because every element in the codomain is having what? A distinct element in the domain. And this function also is injective. But let's assume we are adding 4 to it, and we have this. You can see this is not injective again, because this is not 1 to 1. It is 1 to 2. But it is what? It is surjective. Since every element in the codomain is having at least an element in the domain. Now let's look at this example again. We have A, B, C, and let's assume we have 1, 2, 3, and 4. They can mix A to 1, they can mix B to 2, they can mix B to 3, and we have C to 4. It is also what? It is also surjective. And also, let's look at this A, B, C. We have it as 1, 2, 3. We have A to 1, we have C to 3, and we have C to 2. This is also what? Is also surjective, because every element in the codomain is having a distinct, at least a distinct element in the domain. Do we get that? So it's simple. But we don't want to be looking at all this graphical representation, because what we want to look at basically is not the graphical. They are going to give us a function to test whether it is surjective or not. So for this, we are meant to know some conditions. And what is the conditions that will make a function to be surjective? Now, the first thing is this. Don't forget that they are going to give us f of x. Now, for this, you are going to equate your f of x to y. Do we get that? They are going to give you f of x. You equate your f of x to y. And after that, you now make your x the subject of the formula. So after making your x the subject of the formula, what will you now do? The fourth one is this. You will now insert that value of x inside the function of x. Do we get that? They are going to give us f of x. You equate your f of x to y. After that, you make your x the subject of the formula. After that, you insert the value of x inside the function. And after that, if your f of x is now equals to y, that makes the function to be what? To be surjective. Do we get it? The condition for surjective is different from injective. For surjective, we have f of x, you change it to y, you make your x the subject of the formula, you insert your x inside the function, and if your f of x is equals to y, that makes it to be surjective. For example, let's look at this. They said if f of x is equals to 1 over 2x, don't forget that we have solved something like this earlier, that we said this function is what? Is injective. Now they said is f of x surjective. So they said is this function surjective? So what are we going to do? We follow the principle of what? Of surjective. That is the principle that will make a function to be surjective. And what is that principle? They gave us f of x is equals to 1 over 2x. So what are we meant to do? You are meant to what? To change your f of x to y. So if you change your f of x to y, what do we have? 1 over 2x. And after that, you are meant to make your x the subject of the formula. So let us make our x the subject of the formula. That will give us what? X is equals to 1 over what? Over 2y. Now, since we are having x is equals to 1 over 2y, what will you do? You are now going to insert this function of x inside the formula. Do we get that? So if you insert the function of x inside the function, what are we going to have? We have it as what? F of x is equals to 1 over 2x. And what is that x? That x will give us 1 over 2y. Are we getting that? So from here, 2 will cancel 2. What do we have? F of x is equals to 1 over 1 over y. And that means your f of x is y. And we have said it that if, don't forget, if is a conditional statement. So if your f of x is equals to y, that makes the function to be what? To be surjective. So since your f of x is equals to y, that makes this function to be what? To be surjective. Do we get that? It's simple. Now let's look at another example under this. Now they said if f of x is equals to 2x minus 5, is that function surjective? So how can we make this function to be surjective? We have said it. Just follow the conditions. And what is the condition? The condition is for you to change your f of x to y. So if you change your f of x to y, we have it as y is equals to what? Is equals to 2x minus 5. After changing your f of x to y, what will you do? You make your x the subject of the formula. So making your x the subject of the formula, what do we have? Y plus 5. And that will give us x is equals to what? Y plus 5 over 2. And we have said it. The function is what? After making your x the subject of the formula, what will you now do? What you are meant to do is what? Is to now insert this function of x inside this function. So inserting the function of x inside the function, what do we have? 2x. And what is that x? Y plus 5 over 2 minus 5. Do we get that? And then you simplify. That means 2 will cancel 2. What do we have? F of x is equals to y plus 5 minus 5. And from this, our f of x is equals to y. And since your f of x is equals to y, that makes the function they are giving you to be surjective. Do we get it? So that is that for surjective. So we have looked at injective and also we have looked at a surjective. We have looked at the meaning of injective. We have looked at the meaning of surjective. We have looked at the conditions that will make a function to be injective. And also we have looked at conditions that will make a function to be surjective. Without wasting time, let us move on to a bijective mapping, or what we term as what? A bijective function. Now, what is the meaning of bijective mapping or bijective function? You need to know that from the word bijective, bijective is both one-to-one and what? And onto. So that means if a function is both injective and surjective, that makes the function to be what? To be bijective. Do we get that? If a function is both injective and surjective, that makes the function to be what? To be bijective. So graphically, we have A, B, C, and also we can have 1, 2, 3. So we have A to 1, we have B to 2, we have C to 3. You can see this function is injective. Why? Every element in the domain is having a distinct element in the codomain, and it is not overlapping. And what is the meaning of onto? It is surjective because every element in the codomain is having at least a distinct element in the domain. So that means this function is what? Is both injective and both what? Surjective. And also, if you look at the previous examples we have been solving, we look at f of x is equals to what? 2x minus 5. We have proved that this function is injective with a condition. We have also proved that this function is what? Is surjective. Automatically, this function is what? Is bijective. And also from the previous example, we have proved that this function also is injective and this function is what? Is surjective. So that means since these two functions are injective and surjective, that makes this function to be what? To be bijective. Do we get that? It's simple. Now, without wasting time, let's look at the next type of function. And the next type of function, we don't have a condition to it, we just have it as graphical. Now, we have many to one. Now, from the word many to one, that means if we are having many elements to one element, that means many domain linking to, let's say, at least one codomain. We term it as what? As many to one. Now, for you to understand, let's look at the graphical method. And the graphical method is this. We have A to 1, we have B to this, and we have this to this. This is what? Many function to one function. Do we get that? And also, we can also have it like this. A, B, C. We can have it as 1 to 2. We have A to 1, we have B to 2, we have C to 2. This also is what? Is many to one. Do we get that? And don't forget, this function is, we can term it as many to one, we can term it as what? As surjective. But it is not injective because it is not one to one. Do we get that? And this function is not injective because it is not one to one, but it is surjective and it is what? It is many to one. So that is the meaning of many to one. And without wasting time, let us look at the meaning of constant mapping. And if we are talking of constant mapping, I will just explain with the graphical representation. So if we are having a constant mapping, let's say we have A, B, C, and here we have 1. This is 1A to this, we have B to 1, and we have C to 1. This also is what? Is a constant mapping. Is a constant mapping. What is the meaning of constant mapping? Every element in the domain is having just an element in the codomain. Do we get it? Every element in the domain is being linked to an element in the codomain. So that means this is a constant mapping, this is a constant mapping, and also a many to one mapping, but this is not a constant mapping because the element in the domain is not linked to a codomain. Do we get it? And not to waste time, let us explain the meaning of identity mapping. Now, when we are talking of identity mapping simply means IX. Or it's not IX, but it's I underscore X. So what is the meaning of identity mapping? Identity mapping is simple. The meaning of identity mapping simply means every element in the domain is having the same element in the codomain. Do we get that? So that means if you are standing in front of a mirror, who will you see? You will see yourself. And that is the meaning of identity mapping. So for identity mapping, if we have a function to be ABC, and also we have this function to be ABC, A is linked to A, B to B, C to C. This function is what? Is identity mapping. So we have summarized the conditions and the meaning of it. Now, let's look at some practical examples. Let's look at this. They said if x is equals to 3, 4, 5, 6, and y is equals to A, B, C. They said f is equals to 3 to A. They said 4 to B. They said 6 to C. Now they said the function is dash. So let's look at this graphically. So what is your input variable? Your input variable is the domain, and that is 3, 4, 5, 6. And what is your output variable? A, B, C, which is your what? Your codomain. Now they said you should link your 3 to A, you should link your B to 4 to B, and you should link your C to 6. So which type of function is this? We have looked at the graphical method. This function is not injective just because every element in the domain is not linked with the codomain. But this function is what? Is surjective. Do we get it? So it's simple. Now let's look at another practical example to this. And for this, they said let x be minus 1, 1. And they said f of x is R to R. Now we now have it as f of x itself is sine pi x. Wow. So how can we solve this? That means we are to insert to get our output variable. So if your x is minus 1, what is your output variable? Your output variable will give us sine what? Pi minus 1. And this is a reduction formula. Sine will accept the minus. So that means this will give us what? Minus sine pi. And what is sine pi? That will give us sine 180. And what is sine 180? Sine 180 will give us 0. And also we have s is equals to 1. And that will give us f of x to be what? Sine pi 1. And what is sine pi 1? That will still give us sine pi. And what is sine pi? Sine 180. And that will give us 0. That means the input variable is minus 1 and 1. And what is your output variable? Your output variable is 0. So that means this function will link to this and this function will link to this. So from this graphical representation, you can see that the function is not injective, but the function can be surjective or what? Or many to one. So let's continue to look at more examples under this. Now let's look at this question. I love this question. Now they said let x be set of integers. Now we have let y be set of positive integers. We have f of x is n raised to power 2. Now let me put n here not to confuse you. Now we have n raised to power 2. They now said, what is the function if the domain is x? And what is the function if the domain is y? Wow. So let's look at the first example. When your domain is x, what is your x? Sets of integers. Now let's look at this. What are the sets of integers? The set of integers, what is the meaning of set of integers? That means a combination of positive and negative whole number. So that means, for example, we can have minus 1 and 1, we can have minus 2 and 2, we can have minus 3 and 3. That are sets of integers. But when we are not talking of the set of positive integers, what do we have? That means positive whole number alone. And that will give us 1, 2, 3. Now, so that means if this is your domain, set of integers, and you are inserting it inside a function, what are we going to have? Which type of function are we going to have? That means minus 1, 1, minus 2, 2, minus 3, and 3. So that means if your input variable is minus 1, what is your output variable? We have 1. If your input variable is 1, put 1 here. What do we have? We still have 1. So that means this will be the type of the function. If your input variable is minus 2, put minus 2 here. What do we have? We have 4. If your output variable is, if your input variable is 2, what do we have? We still have it as 4. That means this will be linked to this, and this also will be linked to this. So which type of functions is it? You can see that this function is not injective. It can be surjective or what? Or many to one. Now let's now look at it when your input variable is set of positive integers. That means there is no negative. That means we only have 1, 2, 3. So if your input variable is 1, what is 1 squared? 1. If your input variable is 2, what is 2 squared? 4. If your input variable is 3, what is 3 squared? 9. And this will link to this, this will link to this, this will link to this. And which type of functions is this? This will give us what? It shows that it is injective, it is surjective, and it is what? It is bijective. Do we get that? Since it is both injective and surjective. And that is that about that. Now for the last aspect of this video, and then we release the concluding aspect of mapping and function. For the last aspect of this video, we want to look at limit. Now before we look at limit, limit is simple. It just means you substitute. But what is the meaning of limit? For you to apply limit, you have to know that we substitute. But before you substitute, you simplify. That's the meaning of limit. Do we get that? You substitute the value of x or any function they are giving you. But before you substitute, you simplify. Now let's just look at this. We have f of x is equals to x minus 3. They said find f of 5. This one, we don't need to do anything. What is f of 5? You just substitute. We have looked at this in the first video. And that will give us our x is 5 and that will give us 2. Do we get that? Now if you have f of x is equals to, let's say we have x squared minus 4 over x plus minus 2. They said we should find f of 2. So how can you find f of 2? This is not talking of limit. That means we just need to substitute. So what is your f of 2? Your f of 2 here, just put your x straight. And that will give us minus 2 squared minus 4 into 2 minus 2. And that will give us 0 over 0. And what is 0 over 0? It will give us what? Undivided. And that is that about substitution, not limit. But when we are talking of limit, what is the meaning of limit? We have to simplify. So for this question, let's look at this. They say find the limit of x tending to 5 of x minus 3. So for this function, x minus 3, can we simplify it further? No. So since you cannot simplify it further, just put your x inside. And that will give us 5 minus 3 is equals to 2. And that is all. But for this, let's look at this. They say limit your x tending to 2 of x squared minus 4 over x minus 2. But looking at this, we have said this. There is difference between substituting and what? And limiting. Limiting means you have to simplify first. But we can still simplify this function. And this is the difference of 2 squared. That will give us x minus 2 and what? And x plus 2 over what? X minus 2. And this we cancel this. What do we have? We have it as x plus 2. Now after limiting, you are now going to put your x to 2. So put your x to 2. What do we have? 2 plus 2 is equals to what? Is equals to 4. Do we get that? Can we see the difference between limit and normal substitution? Now let's still look at some questions again. Now let's look at this. They said we should limit x tending to 2 of x squared plus 2x minus 1. Can we simplify? We cannot simplify for anything to cancel. So that means just put your x straight. So if you put your x straight, what do we have? We have 2 squared plus 2 times 2 minus 1. And that will give us what? 4 plus 4 minus 1. And this will give us what? Will give us 7. It's simple. Now let's look at this. We have the limiting of x tending to 2. We have x raised to power 2 minus 9 over x minus 3. The same thing, you can still simplify. That is limit. You simplify first. And that will give us x minus 3 into what? Into x plus 3 over what? X minus 3. This will cancel this. That means we now have the limit of x tending to 2 of what? Of x plus 3. So put your x as 3, 2. What do we have? 2 plus 3 is equals to 5. It's simple. And let's still look at it. We have the limit of x tending to 2 of x squared minus 4 over the square root of x minus 2. Wow. So how can we solve this? It's simple. That means normally we are meant to what? To simplify. We can still simplify. And it is a taboo for we to have what? A square root at the denominator. And if you are having a square root at the denominator, what are we meant to do? We are meant to what? To rationalize. And if you rationalize, this will give us x minus 2 and what? And x plus 2 into the square root of x minus 2 divided by what? X minus 2. This will cancel this. And what do we have? X plus 2 into what? Into the square root of x minus 2. And after simplifying, then you limit your x to 2. So limit your x to 2. Just put your x as 2. 2 plus 2 will give us what? 4. And what is 2 minus 2? That will give us 0. The square root of 0 is 0. And what is 4 times 0? That will give us 0. Do we get that? So it's simple. Now let's look at 2 more questions under this. There is a question that we term as what? As horizontal asymptotes. And that is when we have something like this. They say limit your x tending to infinity. We have 2x cubed plus 5x squared plus 6x divided by x cubed plus 2x squared plus 3. Let's assume we are having this question and they are asking us to limit our x to infinity. See, if they are asking you to limit your x to infinity, that is what we term as what? As the horizontal asymptotes. We are still going to drop a video on horizontal asymptotes under the differential calculus. But for the sake of this video, what is the meaning of horizontal asymptotes? Horizontal asymptotes simply tells us to divide this function by the highest power of x. Do we get that? And what is the highest power of x here? That will give us s cubed. So that means you divide everything by s cubed. That will give us s cubed. This also you divide by s cubed. This also you divide by s cubed. This also you divide by s cubed. All the functions you divide it by the highest power of x. And if we have this, then what do we have? That means this will give us 2 plus 5 over x plus 6 over x squared over 1 plus 2 over x plus 3 over x cubed. So after dividing through by the highest power, then we are now going to limit our x to infinity. And if you limit your x to infinity, that means you put your x to be infinity. And please note, any number over infinity will give us 0. So if you put your x to be infinity here, this will give us 2. All this man will give us 0. Over 1. All this man will give us 0. And what is the answer? That will give us 2. Do we get that? So it's simple. And lastly, let's look at this example. And that is talking of what? Of rationalization. Do you know that it is not only the denominator you can rationalize when we are talking of such, you can also rationalize your numerator. For example, we have the limit of x tending to 3, the square root of 2 minus x minus 1 over 2 minus x. Now, how can you solve this? Please don't just insert. If you insert, it's wrong. So that means what we are meant to do here is what we rationalize. And you can rationalize also. Basically, we have three types of rationalization. The first is when we want to rationalize our denominator. The second is when you want to rationalize your numerator. And the third is double rationalization involving your numerator and your denominator. So for this, we are meant to rationalize our numerator. And if you want to rationalize your numerator, what will you do? You multiply through by the conjugate of your numerator. Do we get that? You multiply through by the conjugate of your numerator. And if you are having this, what are we going to have? This time this will give us what? 2 minus x. This time this will give us, it will cancel since it's conjugate. So this time this will give us 2 minus x. This time this will give us minus 1 divided by 2 minus x into the square root of 2 minus x plus 1. And if you solve this, what do we have? 2 minus 1 is what? Is 1 minus x divided by what? 2 minus x. The square root of 2 minus x plus 1. Though we are still meant to rationalize this, but just rationalize 1. And after that, you limit your x tending to 3. So if you limit your x to 3, just put your x as 3. That will give us 1 minus 3 into what? Into 2 minus 3. We have it as what? The square root of 2 minus 3 plus 1. And what do we have here? This will give us minus 2. This will give us minus 1. This will give us the square root of what? Of minus 1 plus 1. This will cancel. And lastly, that will give us 2 over, what is the square root of minus 1? I. Do we get that? And that is that about that. And under complex number, we cannot leave our answer also like this, just because we are having complex number at the denominator. And if you are having a complex number at the denominator, though this is your answer, but we cannot accept this. So what will you do under complex number? You still multiply by the conjugate of the denominator. And if you multiply by the conjugate of the denominator, that will give us 2 into I minus 1 over what? I squared minus 1. Do we get that? And what is the meaning of I squared? We have a lot of things to still look at. We will still release a video on complex number. You have to know that the square root of minus 1 is I. And when you square both sides, your I squared will give us minus 1. So that means anywhere you are saying I squared, your I squared is minus 1. And this will give us 2 into I minus 1 over what? Minus 1 minus 1. And what is minus 1 minus 1? That will give us 2 into I minus 1 over minus 2. And this will give us minus into I minus 1. And this will give us 1 minus I. Do we get that? So the limit of that function is what? Is 1 minus I. So it's simple. It's simple. It's simple. So that is a normal method of solving. But let me give you a shortcut and then we stop this video on that. Now, this question is talking of the limiting of x to 3, the square root of 2 minus x minus 1 over 2 minus x. Though this is a normal way of solving, but in case you are doing CBT question, let's attempt. See, what you are meant to do here is just to insert the values. Anywhere you are saying square root under limit, just put the values here. So if you put the value here, that will give us 2 minus 3 minus 1 over 2 minus 3. So what is this? That will give us the square root of minus 1 over minus 1. And what do we have here? I minus 1 over minus 1. And that will give us minus into I minus 1. And that will give us 1 minus I. So we are still talking of what? Of the same. Do you get it? So if you are having it in theory question, you are meant to rationalize the numerator and you solve like this. But for example, if you are having it in CBT questions, just insert your values and that is all about that. I remain my humble self, Salami Titilopadini, and we promise to still release a video, just the last video under mapping and function, and that will cover what we term as what? As the limit and continuity. It will also cover the continuous and what? And discontinuous. Please and please do well to click on that subscription button, and don't forget to like, don't forget to share, and don't forget to leave a comment. I remain my humble self, Salami Titilopadini. I love you. Thank you always for watching. Thank you, thank you, thank you.